The gut microbiome is increasingly recognized as a powerful regulator of human health, extending its influence far beyond digestion to impact immune function, brain health, metabolic balance, and even cellular aging. Among the most exciting frontiers of this research is the emerging link between gut health and telomere preservation. Telomeres, the protective caps at the ends of chromosomes, are highly sensitive to inflammatory and oxidative stressors, which accelerate their shortening and contribute to cellular senescence and age-related decline. By improving microbial diversity and reducing gut-derived inflammation, targeted modulation of the microbiome through probiotics, prebiotics, and dietary fiber appears to offer a compelling, indirect path to supporting telomere health. One of the central mechanisms by which the gut microbiome influences telomere dynamics is through its regulation of systemic inflammation. An imbalanced gut, or dysbiosis, can lead to increased intestinal permeability, commonly referred to as leaky gut, allowing endotoxins like lipopolysaccharides, LPS, to enter the bloodstream. These microbial toxins activate the immune system and trigger low-grade chronic inflammation, a known contributor to accelerated telomere shortening. Conversely, a balanced microbiota dominated by beneficial species such as Lactobacillus, Bifidobacterium, and Akkermansia helps to reinforce the gut barrier, limit endotoxin translocation, and produce short-chain fatty acids, SCFAs, like butyrate that have potent anti-inflammatory effects. These systemic benefits create a biological environment in which telomeres are better protected from inflammatory degradation. In particular, butyrate stands out as a key microbial metabolite that may indirectly shield telomeres. Produced during the fermentation of dietary fibers by gut bacteria, butyrate not only strengthens the gut lining but also inhibits histone deacetylases, influencing gene expression related to inflammation and cellular repair. Emerging evidence suggests that butyrate can enhance mitochondrial function, reduce oxidative stress, and promote autophagy, all processes that maintain cellular health and genomic stability. Although direct studies linking butyrate to telomere length are still limited, its role in reducing oxidative burden and maintaining healthy cell turnover aligns well with the broader goals of telomere preservation. Probiotics themselves have shown early promise in modulating these protective pathways. In animal models, supplementation with specific strains like Lactobacillus rhamnosus GG or Bifidobacterium infantis has been associated with reductions in systemic inflammatory cytokines and oxidative markers. Some of these same strains also appear to upregulate antioxidant enzymes such as glutathione peroxidase and superoxide dismutase, which can shield telomeric DNA from oxidative insults. While large-scale human trials directly assessing the effect of probiotics on telomere length are rare, preliminary clinical studies in aging populations and those with metabolic syndrome have reported improved biomarkers related to oxidative stress and inflammation, suggesting an environment conducive to slower telomere attrition. Dietary fiber, particularly from plant-based sources, plays a synergistic role by feeding the gut microbiota and promoting SCFA production. Diets rich in vegetables, fruits, legumes, and whole grains, like the Mediterranean or plant-based diets, have consistently been associated with longer telomeres in epidemiological studies. These dietary patterns not only improve gut microbial diversity, but also deliver a range of polyphenol and micronutrients that independently protect against telomere shortening. Importantly, fiber and polyphenol work in concert with the microbiota. Fiber is fermented into SCFAs, while many polyphenol require microbial transformation into their bioactive forms. Moreover, the gut-brain axis may represent an additional pathway by which probiotics and a healthy microbiome influence telomere length. Chronic psychological stress is a well-established accelerant of telomere erosion, and the microbiome plays a central role in modulating stress resilience via the production of neuroactive compounds like GABA, serotonin, and dopamine precursors. By influencing the hypothalamic pituitary adrenal (HPA) axis, probiotics may help regulate cortisol levels and reduce the physiological impact of stress on telomeres. Some clinical trials involving psychobiotics, probiotics targeting mood and cognition, have shown reductions in perceived stress and cortisol levels, both of which have been independently linked to telomere preservation. Overall, microbiome modulation represents a gentle yet profound approach to telomere support. Unlike pharmacological interventions that target a single aging pathway, improving gut health affects multiple systems simultaneously, reducing inflammation, quelling oxidative stress, improving nutrient absorption, balancing immunity, and even enhancing psychological well-being. These systemic benefits form the foundation of a cellular environment in which telomeres can remain intact for longer, reducing the risk of premature senescence and functional decline. Future research will no doubt expand on these findings, particularly through precision probiotics tailored to individual microbiome profiles and synergistic combinations with polyphenol, NAD, boosters, or fasting regimens. For now, the science strongly supports the integration of probiotic supplements, prebiotic fibers, and diverse plant-based foods into daily routines, not just for digestive health, but as a practical, evidence-informed strategy for slowing cellular aging from the inside out.